Using the Morris theorem to find the end root of unity. All right, class. So today we want to look at using the De Morris theorem to find the end root of unity. Using the De Morris theorem to find the end root of unity. All right. So now, what we can look at this point is that when you consider the equation, let's say z squared is equal to 1. And we know that the z is always representing a complex number with a real part and with an imaginary part. What we can say is that this very equation has this familiar solution. This very equation has the familiar solution that if z squared is equal to 1, then we can take the square root of both sides. And when we take the square root of both sides, the square will take this one away and we get z, which is equal to plus or negative 1. Plus or negative 1. Yeah, so this is a familiar solution that we all know since the square root came into play. However, we can now solve the general equation. If we have this, then we can now solve a general equation when you have z exponent n, which is equal to 1. When you have z exponent n, which is equal to 1. So this is a general equation. When you have a general equation and you have to find the end root, then we can now solve this particular general equation. All right. Now, how do we go about it? How do we go about it? So if we have Zn, which is equal to 1, what happens is that Zn, which is equal to 1, has n number of solutions. It has n number of solutions. Zn, which is equal to 1, has n number of solutions. So now, if Zn is equal to 1, then we can say Zn is equal to the exponent of 2I k pi is equal to e the exponent of 2I k pi as established earlier on in the trigonometric function. Yeah, that the theta has the same angle rotation as 2m pi. So now in this case, where the k is what? An integer. The k is an integer. So now if the zn is equal to 1, then we can say the z, which is the complex number, will be equal to this. And if that is the same, now taking the nth root of each side, taking the nth root of each side of the equation, if you want to take the nth root of each side of this particular equation, then how do you go about it? So to take the nth root, we get Zn is equal to e exponent, the exponent 2I k pi all divided by n. So this is when you are taking the nth root of this very equation. So the nth root of this very equation will give us what? 2I k pi all divided. It's very simple. It's more or less like when you have a number raised to the power half, it's the same as what? The root of that number. So if you have a number raised to the power 1/3, it's the same as what? The square root of the number, the third root of what? Of that particular number. All right. Okay. So with this understood, the solutions for the equation. This understood, the solution for the solution of Zn is equal to 1. You have some number depending on the number of the n. You have Z1, Z2 exponent, which is up to Z. That is to say, if it is Z cube exponent 1, that means we're having 3 solutions. If it is Z cube exponent, Z exponent 4, we're having 4 solutions. That's why I said Zn equal to 1 means that we have n number of what? Of solutions. And this one is equal to 1 divided by 1 comma e exponent 2I pi on n, straightforward to e exponent 2I n minus 1 pi all divided by n. So now, with the n number of solutions, these are the solutions you get. These are the solutions you get. Why? Because we will start from 0, 1, 2, up to n minus 1 for all k values. For all k values. For all the k values. So for instance, if you are given a question and you are asked to find maybe z squared is equal to 1, then we start with e exponent what? 2i, k now here becomes 0. So which is 0 times what? Pi over what? Over the n 0. So now you realize that this is the same as e exponent what? Of 0, and it will give what? 1. That is why the first value we got here was what? Was 1. Alright. So understanding this, let's take a typical question. Let's take one question. Alright, so let's take one question. And the question says that we should find the solutions. Find the solutions of the equation. We should find the solutions of the equation z cubed is equal to 1. Z cubed is equal to 1. So now, this is the equation that we have been given. And we have been asked that we find the solutions of this equation. Now, when we started, we said if you have Zn is equal to 1, then the solution is Zn will give you what? We write the equation as Zn, which is 2i k pi, all divided by what? All divided by n. Alright, so now the n we are having in this question is 3. That means you are supposed to have 3 solutions. At the end of it, you are supposed to have 3 solutions. So we range the k values from what? 0, 1, from 2, and to what? On to 3. So these are the k values you'll be using. Alright, so now you have to have 3 solutions. So the 3 solutions you get from this question are 1. You have z cubed, which is equal to 1. So therefore we can get the z cubed as a result of e exponent 2i k pi all divided by 3. Are you getting it? Okay. So now the solutions you must have one. Z1. So our first solution, because it's z cubed, must have 3 solutions. So our first solution we get here is what? It's when the k is equal to 0. That is our first solution. So our first solution, when the k is equal to 0, then what do? We realize that we get 2i k 0 pi all divided by n. But because of the 0 here, it makes it undefined. So we get e exponent 0i, which is equal to what? 1. E exponent 0i, which is equal to 1. So our first solution, z1, is equal to 1. Our first solution, z1, is equal to 1. Okay, let's look at our second solution, z2. Alright, so our second solution, z2, that one will give us what? When n is equal to, k is equal to 1. So when k is equal to 1, our z2 will be having e of 2i times k pi all divided by, so this one is the n is already 3, so yes, 3 all divided by 3. Okay, so now when you get this, you have our z2, which now becomes e of 2i pi all on what? All on 3. And this is our second solution. Now lastly, our third solution, we have to finish everything, but at the end of it all, we have to get only 3 solutions. So now, when n is equal to 2, when k is equal to 2, we have our third solution z, which is equal to e exponent 2i 2 pi on n, which is 3. So when you do this, you will get e exponent 4i pi all on what? All on 3. And this is our third solution. Now let's look at when k is equal to 3. Whether it will give us another solution. So if k is equal to 3 and it gives us another solution, that means the whole question is wrong, or the whole principle is wrong. So now we get z4, which is equal to e 2i into bracket 3 pi all divided by what? 3. So now, let me write it here. Our Z4 now is equal to, this multiply that to give you 6, sorry. E of 6I pi divided by what? 3. Now, our Z4, which is equal to E of 6 pi divided by 3. 3 goes into 6, how many times? That is 2. So that's giving E of what? 2I pi. That gives you E of what? 2I pi. Now the E of 2I pi is the same as 1. If we find this, the E of 2I pi will give you 1. The E of 2I pi will give you 1. So now, that means the Z4, which is equal to 1, is the same as what? Our Z1. So we have only 3 solutions, and our 3 solutions now becomes 4. Z cubed equal to 1 is now 1. Our second solution was what? E of 2I pi on 3 and E of 4I pi on 3. And these are the 3 solutions for the complex number of Z cubed is equal to 1. So you can take time and work on this. It will give you 1. E of 2I pi. You can take time and work on that. But you got to take note that the I there is equal to what? The root of what? Negative 1. Kindly put it on your calculator and you get 1. Thank you very much for this lesson.